Good morning, everybody. There's probably not going to be anyone here live because of the storms yesterday. I think there's some power outages in Asheville, so I'm just going to go ahead and make this, though, and then y'all can go back and watch it. Hey, Leah. This is Advanced Algebra 1. I will be doing the live video for your class tomorrow. I sent a quiz through Teams, though, so check Teams. Algebra 2 has a quiz that's due tomorrow. All right, so today, let me get my computer fixed to where I can look and see what I'm doing. All right, and we will get started. Brittany Engel, there's one of my students. Hey, Brittany. There's probably not going to be anybody else on. I don't know. There's a lot of power outages, I think, around Asheville. And my Wi-Fi has been acting crazy. But we'll see if we can get through this. By the way, Brittany, I sent a quiz through Teams that's due tomorrow. It's just a little 5-problem quiz on what we've already been doing. So just check your Teams after this video and do that. Okay, so today we're going to be doing more multiplication with radicals. Also, I believe after this video, I'm going to do another video of an alternate method to simplify radicals. So whenever you get a really big number under the square root symbol, you won't have to go through so much dividing on the perfect squares. You won't have to worry about perfect squares. So I'll do that video, and I'm going to send it out to everybody, the link, in case they're still having trouble with simplifying. It might help in some of these problems too. But we are going to be doing more multiplication with radicals. We have two goals. We're going to be multiplying using the distributive property. And then we're going to be multiplying using the FOIL method. So, let me look to see if this is clear. Well, it's pretty clear. Okay. So, example 1. We're going to multiply the square root of 2 times negative 9 plus the square root of 3. So you can see there's parentheses around the negative 9 plus the square root of 3. That indicates we're going to use the distributive property and multiply the square root of 2 times both of those things. Now what you have to remember is that when you multiply, you can only multiply the numbers inside the square root symbol together. So like on this first one, when you multiply the square root of 2 times negative 9, you can't multiply that 2 and that 9 together because this 9 is not inside the radical symbol. So you just have to put that negative 9 on the outside of the square root of 2. So the square root of 2 times negative 9 is negative 9 on the square root of 2. Then you take the square root of 2 and you multiply it by the second term in the parentheses. Both of those are under the square root symbol. So when you multiply the square root of 2 times the square root of 3, you multiply the 2 times 3, and you just get the square root of 6, and put the plus sign down. So plus the square root of 6. Now what you've got to do next is look and see if any of your square roots can simplify, if they have perfect squares in them that you can bring out. The square root of 2 does not simplify any further. The square root of 6 does not simplify any further because there are no perfect squares that divide into those. So that is your answer. All right, before I move on, Brittany, did you understand that one? Okay, good. So we are going to move on to the example 2. So on example 2, I'm going to multiply negative square root of 3 times 10, and then negative square root of 3 times this negative square root of 3. So when you multiply these first two, again, this 10 is not under the square root symbol. So you're just going to write negative, because it's a negative times a positive, 10 on the square root of 3. And then you move over and multiply negative square root of 3 times this negative square root of 3. And a negative times a negative is a positive, so you put plus. The square root of 3 times the square root of 3 is the square root of 9, 3 times 3. One thing I want to point out on your IXL, make sure that when you type in like this radical, negative 10 on the square root of 3, before you put your plus sign, make sure you've moved your arrow or your cursor on your screen away from this radical. You do not want to continue with a plus sign underneath that same square root, so be careful with that. On this one, you do have to simplify the square root of 9 because that is a perfect square in itself. So you're going to come down and say negative 10 on the square root of 3 plus the answer to the square root of 9, which is just 3. And that is your answer. You cannot add those together because the radicals are not the same. Make sure you know, after I've gone back and put the box around it, it's hard to see where my square root is. Because it stops here. Remember, don't let it continue over the plus and the 3 on the IXL or it's going to count it wrong. Okay, example 3. We're going to move on to negative square root of 35 times 7. And again, you cannot multiply those because this 7 is not under the square root symbol. So you're just going to write negative 7 on the square root of 35. Make sure you move the arrow out of the square root on your IXL. And then you multiply negative square root of 35 times positive square root of 7, which is going to be a minus. And then we've got to multiply 7 times 35. Which is 245. Okay, so now we have to simplify the square root of 245. It's not a perfect square, but we need to simplify it. It does have a perfect square that will divide into it. And so I'm going to come down and rewrite negative 7 on the square root of 35. Negative times a negative is a plus. And now I've got to find a perfect square factor of 245. Now, whenever your number ends in an odd number, I always check to see if perfect squares like 49, 85, 121, any of those odd perfect squares will divide into it. So let's check and see. I'm going to check 49. 245 divided by 49. Yes, it goes 5 times. So 245 is the same thing as 49 times 5. Now this right here, if you still have trouble with simplifying the square root of 245, I'm going to show you another way that later in another video. You don't have to watch that video. But for anyone that's still having trouble, they can watch that video, and then it's going to show you an alternate method to simplifying those. Alright, so now we've got to simplify by taking the square root of 49, which is 7. So I'm going to have negative 7 on the square root of 35, plus the square root of 49 comes out as a 7, and you're left with your 5 under the square root. These two numbers under the square root are different, so you can't go any further. You can't add or subtract those, and that is your answer. I'm not going to put a box around it because it interferes with my square root symbols. And we have one more example with the distributive property, and then we're going to move on to the FOIL method. So, the square root of 15 times negative 6 minus the square root of 3. So we're going to start by multiplying the square root of 15 times negative 6. And that's going to be negative 6 on the square root of 15. And then the square root of 15 times the square root of 3. And there's a minus in front. So it's going to be minus the square root of 45. Now you need to look at your square roots, see if either one of those can be simplified. 15 cannot, because there is no perfect square factor in 15. 45 can, because there is a perfect square factor in 45. It's 9. So this is negative 6 on the square root of 15 minus the square root of 9 times 5. And then you just have to simplify the square root of 9. So rewrite your negative 6 on the square root of 15 minus, take your square root of 9, which is 3. That comes on the outside, and you're left with your 5 on the inside. Now let me go back, because this, it's hard to see that 1. There's a 1 there. That's a 15. So because that's a 15 and that's a 5, you can't add or subtract these. So that's your answer. So that gets our first goal, multiplying using the distributive property. And now I'm going to move on to example 5 and do a couple of problems with the FOIL method. Let me make sure you can see those. All right. So, example 5. When you see a problem like this, what you should recognize is that there are two binomials side by side in parentheses. So, remember you can either use the distributive property or the FOIL method. And so I'm going to do the FOIL method just because I want y'all to be able to do it quickly, as quick as possible. So that will be using the FOIL method. Okay, so remember, and I'll just write FOIL up here, F-O-I-L. So we have to multiply the first terms in each parentheses together. Let me make sure that it's not blurry. It looks like it's going in and out, maybe. Alright, so multiplying the first terms together, negative 8 times 2 is negative 16. And then remember, the O in FOIL stands for outside, so we got to multiply the outside terms, which is really this first one and the last one. Now, when you multiply those two terms, you've got this negative 8 that has to multiply by this negative 8 on the outside of your radical. So negative 8 times negative 8 is a positive 64. And then you just put the square root of 15 behind it. And then you move to the insides, the I in FOIL. So we're going to multiply this negative square root of 3 times 2, which is negative. Remember, you can't multiply the 2 and the 3 because this 2 is not under a square root. So it's going to be negative 2 on the square root of 3. And then you move to the last terms in each parentheses. So we're going to multiply this negative square root of 3 times this negative 8 on the square root of 15. So, let's just look at it again. There's nothing in front of that radical to multiply by that 8. So, it's just going to be a plus 8 on the square root of 3 times 15, which is 45. Now, some of your IXL problems, I think, you're going to be finished with those 4 terms. But on this particular problem, this 45 can be simplified because remember, 9 divides into 45. And on any problem ever, when you're simplifying square roots, if there is a perfect square factor in the number under the square root symbol, you've got to simplify it. Alright, so this negative 16, everything on this line I'm just going to rewrite except for that 45. So negative 16 plus 64 on the square root of 15 minus 2 on the square root of 3 plus 8, and then 45 I'm going to factor as 9 times 5. So now we need to take the square root of the 9 right here. So again, I'm going to rewrite everything that's in front of that. Negative 16 plus 64 on the square root of 15 minus 2 on the square root of 3 plus, now right here, the square root of 9 comes out as a 3, and you've got to multiply that 3 times the 8 that's in front of the radical. So that's going to be 24 on the square root of 5. Then go back and look to see if any of these square roots have the same exact number under the radical symbol. Because if they do, remember, you've got to add or subtract them, but they don't. So that's your answer. That's it. And again, I want to emphasize, when you enter these answers on IXL, I might have said I now before. When you enter these on IXL, make sure that when you do a square root symbol over a number, you move your cursor out of that box before you do your minus 2, or it's going to continue underneath one long square root and it's going to count it wrong. All right, Brittany, are you still with me? If you're still with me, do you understand it? Okay, good. We've got 2 more examples. Example 6. We're going to multiply, again, using the FOIL method. So, starting out, we're going to multiply the first terms together. So, we're going to multiply negative 5 times negative 6. which is positive 30. And then I'm going to move to the outside terms, these two at the front and at the end. So negative 5 times the square root of 11. You can't multiply those numbers, so I'm just going to write it as minus 5 on the square root of 11. And then you multiply the inside terms. The inside terms are these in the middle. And this negative 6 is not under the radical symbol, so you can't multiply the 6 and the 22. So that'd be minus 6 on the square root of 22. And now you multiply the numbers at the end, the last terms, which will be this this square root of 22 times the square root of 11. And that's going to be plus the square root. And let me multiply 22 times 11. And that's 242. When you look through all of these terms, none of the square roots can be simplified except this one I bet can. 242, if you start checking, let's just start with the highest perfect square that you think possibly could divide into 242. Let's start with maybe 144. Nope, it doesn't go evenly. So let's try 242 divided by 121. And that goes 2 times, so that's going to be it. So the rest of these I'm going to rewrite. 30 minus 5 on the square root of 11 minus 6 on the square root of 22 plus, and then I'm going to factor 242 as 121 times 2. And then all you've got left to do, 30 minus 5 on the square root of 11 minus 6 on the square root of 22. All you've got left to do is to simplify the square root of 121, which comes out as 11 on the square root of 2. So looking back at all the terms in the answer, if any of those square roots are the same underneath, then you simplify by adding or subtracting, but they're not. So that is your answer. And then our very last one, this last example, I think is one that you are going to be able to simplify by adding or subtracting at the end, like these 4 terms. I think these are going to have some that we can combine. Okay, so let's see how this one works out. We have multiplying the first terms together. We have 4 times the square root of 2, which is going to be 4 on the square root of 2. And then the outside terms, we're going to multiply this 4 by the square root of 6. And there's a minus in front, so it's going to be minus 4 on the square root of 6. And then you do the inside terms, so we're going to multiply these in the middle. Now both of those are under the square root, so we can multiply those numbers. 3 times 2 is 6. It's positive, so it's going to be plus the square root of 6. And then we're going to multiply the last terms, which will be this square root of 3 times this square root of 6, which is going to be minus, because there's a minus in front, the square root of 18. Okay, so looking through your 4 terms, this last one, the square root of 18, can be simplified. So we have 4 on the square root of 2 minus 4 on the square root of 6 plus the square root of 6. Now remember, if you don't have a number in front, it's understood to be a 1. If you want to put a 1 down to help you with your adding and subtracting, that might help. And then minus the square root of 18 is going to be the square root of 9 times 2. So I'm going to rewrite this line again. 4 on the square root of 2 minus 4 on the square root of 6 plus 1 on the square root of 6 minus 3 on the square root of 2, because the square root of 9 comes out as a 3. Now look what we have. We have two pairs that you can combine, because this 4 on the square root of 2 minus 3 on the square root of 2, those two you can combine into one term because they have the same radical. So remember, you just add or subtract the numbers in front. So 4 minus 3 is 1. 1 on the square root of 2, which is just the square root of 2. You can put the 1 in front if it helps you. And then these two terms in the middle, you can combine those because they both have the square root of 6. Negative 4 on the square root of 6 plus 1 on the square root of 6 is negative 3 on the square root of 6. And that's your answer. Square root of 2 minus 3 on the square root of 6. And that cannot simplify. All right, now your IXL topic, Algebra 1, EE6. You have to get a SMART score of 80. Again, that's Algebra 1, EE6, SMART score of 80. And I went through all the problems. They're pretty much just like these. These are, in fact, are some of the problems that came up on my IXL when I did those. Let me know if you need any help. Remember, there is a quiz on Teams that you need to take either today or tomorrow. And get a SMART score of 80 on these. And I will see you again on Wednesday. Let me know if you need any extra help. Bye.